Dear colleagues, sorry for some technical problem. I think it is not principal. I would like to invite you for our seventh workshop on theory of reliability and Markov modeling for information technologies, TheRMIT, the third 2021. Our workshop is part of activities 7th International Conference on ICT in Education, Research and Industrial Application. It's my pleasure to invite for invited talk our colleagues from United States, Professor Andrzej Rusiński, Professor Tadeusz Polkochanski. And before starting of our invited talk, I would like to say a few words about our workshop. Please, next slide. We thank organizer of this conference. You can see a long list of different organizations, different universities and companies which organized this conference. And the organizers of TheRMIT workshop are National Aerospace University, HAI, Žilina University, and Hellenic Military Academy, Greece. Please, next slide. We have industrial partners as company ready. We have project partners as Echo Horizon 2020 and information partners, Ukrainian Scientific and Education IT Society. Please, next. We thank our sponsors who help with organization of this conference and who prove free payment of our conference during a lot of time. Please, next. Today we open our seventh TheRMIT, the third workshop in framework of ICTRI conference. Previous our workshop we started in Lviv 6 years ago, Kiev, Kherson, Kharkiv, and now we have seventh TheRMIT. Please, next. 1 year ago, we started discussion problem of big safety and global trusted dependability in framework 11th IEEE, the third conference. You see main panelists who started with these topics, and it's my pleasure to invite for next speech, next presentation, my colleagues, Professor Andrzej Rusiński and Professor Kochanski. Please, Andrzej. Before Andrzej talk, I would like, said about problem big safety and security as a result of crossing the environment, including physical information and human complex property or attributes, reliability, availability, integrity, big failure, and a huge value of failures, big number of reasons, big data, big requirements, big time and process complexity of development, implementation, operation, big toolbox as a set of techniques and tools, and big resources for assurance and recovery. We, in framework of our workshop, we will talk about different attributes of big safety and security. First of all, safety, reliability, and security. And there is a problem of application modern information technology, such as Internet of Things, big data, machine learning, augmented reality, and artificial intelligence. This technology bring new benefits, but there are problems with deficits of safety and security during application of such technology. And in COVID time, we have additional challenges related to problem big safety as a whole. Please next. Please, Andrzej, I would like to ask you continue our presentation. Please, Professor Andrzej Rusiński from New Hampshire University, United States. Please.
So thank you very much. And as you can see, the title of our workshop, of our presentation, include the word dependability. And as you can see, after all these initial problems, we together as a team can solve them. So I'm happy to be here and have a short presentation about what we have done thanks to conferences organized together by this international community, including a very heavy contribution from Ukraine. So once again, thank you very much for this opportunity. So to start with, we see those conferences as something which stimulates us to develop new directions in science and research. And one of the efforts which we are still continuing is a new paradigm in the theory of dependable systems, which we call global trusted dependability. So if we look at the definition of dependability, a classic definition, one of them, you can see that it says the ability of a system to deliver its intended level of service to its users. And I would like to pay attention to the word service in this definition. So in this case, if you look at the definition of global trusted dependability, the service becomes not just service, but becomes global service. So from that standpoint, the goals of the global trusted dependability are equivalent to quite well-developed paradigm of grand challenges. So that's one component which differentiates global trusted dependability from a classic dependability. Now, another word in the title is trusted. That's, again, an important word, and it can be related to the architecture of any dependable system, which does assume the existence of core logic or some kind of a subsystem which is assumed to be defect-free, fault-free, failure-free, depending on the substance we are looking into. So in this case, we are assuming that this core-free observer can also be faulty. And the differentiate why it is faulty or not faulty is a question of trust. So we introduce the definition of trust, and that way we have those services which can be either trusted or non-trusted. And the last but not least, in this definition of global trusted dependability, our major goal is to look into the question of quality of life. The quality of life can be defined once again through wellness or well-being. You have a definition here, which is looked into as the condition of an individual, group, or Homo sapiens. So once again, I would like to stress this Homo sapiens is a global notion. So we have this global trusted dependability I'm talking about. Next slide, please. Well, one important thing which, in our opinion, has been overlooked these days is the role of human beings in the whole research and science. So we are assuming that still humans become a central point of everything, what we are observing, what we are looking in the universe. And obviously a symbolic, a symbol of this excellence of humans can be reflected by the Vitruvian Man introduced by Leonardo da Vinci, one of the best known icons in the world. So the research we are conducting is focusing on people in the center. That's why this notion of a Ptolemaic universe type of thing. Now, this human being is associated with its companion. Let me introduce Atlas. This is a robot from Boston Dynamics. You can see it next to it. Next slide, please. Atlas is trying to mimic the Vitruvian Man. You can see it here in a sort of victory position. And it has been created by, next slide, please, by Mark Rybert. Okay, this is the father of the Atlas. So what we are saying is we don't need to focus only on humans, but we have to focus on both humans and its partners from the artificial intelligence world. Now, to put all these things together, once again, on this slide, you can see two icons, one representing the Vitruvian Man, another one representing this Atlas robot. But there is also the third component. We do believe that on the top of this real world, this virtual world, we also have to look at the spiritual world and we can create a formal model which has been done. We call it a reset model. And if you are looking at the slide, coincidentally, it's interesting because it simply comes back from the roots of our civilization, because this model has been created by and promoted by Plato and Aristotle. So the virtual man is sort of the domain of physics. The virtual world is the domain of mathematics, and on top, the spirituality is governed by philosophy. Next slide, please. We have formalized this global trusted dependability theory even further. It is a subset of a reset model, which I shortly described. I also mentioned the name of Plato, and what is interesting, this question of trust is related to the notion of the virtue code, which I showed on the previous slide. To keep it sort of neutral at minimum, we can, for example, use the virtue code introduced by Plato, which is focusing on beauty, wisdom, and goodness. The model assumes as a weighted graph different modes. You can see different colors. When a node can be faulty, can be tested, can be fault-free, and can recover. And also, it is a subset of a theory of system-level diagnosis introduced by Praparata, Metz, and team, which dealt with self-reconfigurable and self-diagnosable computer systems. So let me show you an example what this global dependability, trusted dependability can be used for. And since we still live in the era of coronavirus, you can see different scenarios. What happened in China? You can see that the faulty part of this model can be either real, R, virtual, T, or spiritual. The first case corresponds simply to a scenario when coronavirus started on a market and bats were involved. The technology piece, which is red here, talks about some kind of a leak from the laboratory in Wuhan. And this spiritual red circle marks a scenario when somebody released the coronavirus on purpose. Needless to say, the ending scenario was that R in either cases have become red, which means that our world is right now faulty. Now, the dynamics of what happened has been described superbly by Ilya Ryonov, who was a former advisor to President Putin and now, as far as I know, lives in Ukraine. And according to his scenario, it started in US laboratories when ill-defined research started looking at coronavirus as something which can affect humans. This is the first piece in this process. The process was amplified by the action by the French and the US governments, which established and created institute, the laboratory in Wuhan. This is the second piece. Now, as I mentioned, this accident happened one way or the other. We haven't decided yet what happened. The world hasn't decided yet. And as a result, we have this bad news right now. We are still suffering, all of us in the world, because coronavirus is with us. So the purpose of my presentation is not just to send bad news, but to realize where we are. And now we should be in the process of recovery. And Dr. Kochanski is going to show you one possible scenario, what we can do together. Ted, go ahead. Thank you.
Spasibo. Dziękuję bardzo. So one thing we have thought about is the possibility of making a transition from something that everybody sort of considers to be an iconic paradigm to something totally new. And we call this from where we are now towards two things: a Lunar Academy and a Universem. And why are these two words there? Because there's a heritage. So going back 2 millennium, there was Plato's Academia, and there was the Great Library of Alexandria. Plato's Academia tried to teach, as Andre had pointed out, beauty, wisdom, and proper behavior. And the academy was also a place of fundamental science. It sort of spurred further on the library in Alexandria, which had both a research component and also an archival component. They tried to store the knowledge of the world. Now we are dealing with quantum leaps and bounds, and we can go directly from this heritage to the Lunar Academy and the Universem, where the Lunar Academy is able to take advantage of assets like Alliot, Erasmus, the Infinium, Cypress Semiconductor worldwide classrooms, blockchain technology, fractal networks to build our computing networks, and the Femto Academy, which has been put together by a number of physical academies or physical universities in the Gdańsk, Poland area. And we now come with the Universem and the idea of how IDAX, for instance, could respond to the coronavirus was part of a small discussion at the end of the IDAX conference. And of course, we honor the heritage. If you like ancient Greek, there it is. Now, we also have to celebrate the heritage of a great member of the European community born 100 years ago this year, Stanislav Slam, who lived in what now is several different countries, and they all claim him. Some say he's Ukraine, some say he's Pole, some say he's Lithuanian, maybe. Some say maybe he's Belarus. In any event, Stanislav Slam is responsible for many great works. Many of them are available in this particular bookstore in Poland. Probably in Ukraine, there are many bookstores with his books also. And in particular, there's a 2021 book about Lem. And there's another book which is very well known to many people, which is his sort of satirical investigation of the idea of trying to imagine the future, which he called the Congress of Futurology. And we use this as a motivator for us. There you can see Professor. So the Congress of Futurology is built upon the Universem and at the core of the Universem is what we call the core meta repository. You can see an icosahedron here, representation of knowledge. And you'll see a bit more about that in a couple of seconds. Surrounding the core meta repository is a global all accessibility interface, and I apologize for the failure of the system to do a very good job with the contrast. But the idea is that this global all accessibility interface provides a universal way of translating things. You'll see a little bit about that too. Surrounding that is a blogging area where we basically store everything that is being conversed one way or another, either as a machine kind of to machine thing or as a person to machine thing, or conceivably person to person thing. And this is for several reasons, one of which is to protect it from anybody hacking. Hacking is becoming a big problem with the cyber systems these days. It's a permanent inviolate record, and it also allows us, in case we make a mistake, to fix it. And on the outside, there's the access provided to the end user through what is essentially like a Windows type of interface, which we call the Universem. It's a universal platform that provides the access to the internal layers. So this is a system block diagram. I won't go into all the details, but what you can see quickly is in one column over here, this is all related to the core, the meta repository. There are the concepts themselves. There's a engine that allows you to construct and create new concepts or take away old ones. And there are linkers, which allow various connections to be made amongst them. This is the translation zone, and there are language interpreters, here are nonverbal interpreters for people who, for instance, don't speak English. You can have a language translator. For people who can't speak at all, can't hear, you can have a translation into a nonverbal situation. Similarly, for someone who can't see, you can have a nonverbal translation. And finally, there's a column here which we call vernacular interpreters. And this is how different people respond to the same term in different fields. A physician, an agronomist, a astronaut, all these people might have different ways of using the same concept in their own personal areas. At the other end, we have the users, and the connection between them is this universal access platform of providing the application layers. And in particular, there are these futurology congresses, a blog about the futurology process, and conversations about the content of futurology. And underneath it all, the universal blog tying it all together. So not to go into the details here, but this is more specifications for these things. Now, the meta repository deals with many different kinds of concepts. And we give an example here of some sample classes associated with the word in English, chips. And they come under categories of food. They come under the category of microsystems, the kind of chips that most engineers think of. Well, they sometimes think of these kind of chips also. The product of chipping, for instance, how do you make wood chips, metal chips, or rock chips? And then there are other chips, poker chips, paint chips, which are ways of displaying paint colors, chips in paint, which are pieces of paint that are missing, the TV show that doesn't have any relation to any of those things. And finally, because it's an internationally popular term these days, CDMA, code division multiple access communications, used for cell phones, used for radar signal processing. It's a means of describing the data sequences involved in the coded signals. And this is a visual representation of these things. So we have food chips. These are all kinds of chips. Those are tortilla chips. So if you are Hispanic in the United States, this might be your chip. If you're from England, Anglo-Saxon, this is fish and chips. If you're a more traditional American, this is potato chips. Cape Cod potato chips right here nearby. There are also chips made out of apples. These are dried apples, and these are miscellaneous kinds of chips made out of various fruits and nuts, fruits and vegetables, I'm sorry. These are chips of rock, chips of, over here, chips of rock. These are chips of wood of various kinds, chips of metal over here. This is a statue of Michelangelo's David, which is considered to be the remnants from the best failed block of marble that was about to be thrown out, and Michelangelo decided to hack on it and make a statue. These are the kind of chips he would have probably produced. You can actually see that's a chipping of something very small. Over here, these are these other chips. In fact, this is kind of interesting because this sort of crosses over to some of these other ones. These are epoxy paint chips, which you can buy and make into an epoxy coatings on things. These are chips of paint that fell off things. That's a Tesla car with a chip missing. And these are poker chips. And that happens to be a sort of a piece of art constructed out of these paint chips. And now we get to the microsystems, MEMS, very nice micrograph of a mobile component made out of silicon, a very large piece of silicon with a lot of little pieces of silicon attached to it. This is a radar on a chip with multiple process units and also antennas. And finally, we have a bio lab on a chip and the photonics chips. So we get back to Stanislav Slam. About a couple weeks ago, there was a transmission of this picture to the moon and back to commemorate the centenary of Lem. And we have superimposed the Universem here as the representation that I'm sure Mr. Lem would be perfectly happy to connect himself with. And there's the Lunar Academy popping up, and the user portal and the Futurology Congress as ways of taking advantage of this Universem. And a famous quote, well, simplified version of it: reality is immeasurably richer and incomparably more fantastic than all the figments of imagination. Stanislav Slam, Science and Fiction. This is courtesy of Adam Ustanovich, colleague of ours, who in 1991 produced a film for the BBC with an interview with Stanislav Slam. And then we would like to say to you, thank you. Dziękuję bardzo. Dziękuję bardzo. Yeah.
Sorry. Thank you very much, Professor Rusinski. Thank you very much, Professor Kachansky, for your great presentation. And now we have time for our workshop presentations. We need to check our time schedule. First session of our workshop consists of 3 presentations. I suggest all our presenters to about 20 minutes for your presentation, okay? In general, we have 7 presentations, first and second session. Let's start, and I would like to invite for first presentation Professor Tatiana Shmylova, with your colleagues Maxim Yatsko, Yulia Sikerda. The topic of presentation: collaborative factor models of decision-making by operators of the air navigation system in conflict or emergency situation.
I share. Good morning. Just a moment.
Yes, please share your screen.
Oh, I have problem with screen too. Because don't synchronization between with Google. Firstly, I teach in Google Meet, and I cannot. Just second time I try.
Okay.
Ah, yes. Oh, do you see? Do you see?
Yes, yes. Please start your presentation. Okay.
Good see.
Yes.
Oh, okay. Good morning. I am Shmilova Tatiana. I am from National Aviation University, professor of navigation department system, and co-author Maxim Yatsko, pilot and associated professor, and Yulia Sikerda, associated professor and air traffic controller. And topic of our report, collaborative factor models of decision-making by operators of the air navigation system in conflict and emergency situation. This is our team, pilot, air traffic controller, and I. And our areas of scientific interest with decision-making models in risks, uncertainty, and artificial intelligence methods in aviation, and manned and unmanned aircraft flights in integrated airspace.
Yeah.
And about human factor models, please close microphone.
Please switch off your microphones.
Angie, maybe.
Ted, please switch off.
Yeah.
Ted. Okay. I will continue. Human factor problems, and we know statistical data show that human errors account 80%, and next factor, technical and environment factors, 20%. This is a more percent of in case human errors.
I couldn't understand why I couldn't find the right conference. It didn't exist as far as I could tell, but then
don't listen our. I will continue.
Please continue.
ICAO, International Civil Aviation Organization, recommends using following conceptual model for solution human factor problem and improve flight safety.
Right. Microsoft and Google don't get along very well.
And from shell model, next model, reason model, and safety effectiveness balance model, and now we have artificial intelligence methods and in aviation and flight manned and unmanned aircraft in integrated airspace, and now we have security culture, all conceptual model for responsibility and reliability in aviation. And about this year, 2021, year of security culture, with the communication between personnel in group, in team, and collaborative decision-making too. In the evolution human factor models steps, from shell models and step-by-step include culture, artificial intelligence methods for improve situation in aviation, and now safety culture between human operator in team on job too. And the chronological table you can see on this slide of evolution human factor models from 1970 to now, 2021. And about artificial intelligence. About artificial intelligence wrote in AI white paper, IATA. In this very difficult problem system, but expert system, this is a first step for building artificial intelligence. And in this book, we published about artificial intelligence in aviation and development on all steps of aviation and navigation system. And about building artificial intelligence system. Now, for example, 7 steps. The first step, expert system. Next step, this is a decision-making and collaborative decision-making models for prepare data for artificial intelligence. And next step, artificial intelligence without training data. And next steps with training, machine learning and deep learning. And now a very modern intelligence system of decision-making, combine nature and artificial solutions. This is a hybrid systems for obtained optimal solution or nature or artificial intelligence. but in aviation said that human is main in obtain solution, optimal solution. And for example, separation between aircraft and air traffic management and decision making in emergency. And this model we are building for the decision with problem in aviation. And our contributions, we many writing about decision making in emergency for pilot, for air traffic controller, for engineer, for operator of drones. And now we are studying decision making of group of aviation specialists. This is a collaborative decision making, and especially in emergency. And purpose of this work build individual and collaborative decision-making models for pilot, air traffic controller, and flight dispatch in emergency, and integration models in collaborative decision-making, and develop algorithm of analysis of situation and synthesis of collaborative decision-making models for pilot, air traffic controller, and flight dispatch in emergency. If this is the rules for flight dispatch, pilot, and air traffic controller. This is the rules flight dispatch before flight, pilot responsibility in flight, and air traffic controller only control in airspace in on many aircraft. And this model for all operators, this is a deterministic model, but very complex model. This is a model difficult, many solutions and wishes with undetermined decisions. But after improving this model, we are using decision-making in risk, decision-making in uncertainty, and artificial intelligence methods. If we have large amount of statistical data, we may use decision-making in risk. If we have not large statistical data, we may use decision-making in uncertainty metrics. And in next case, artificial intelligence methods if we have big data. But in aviation problem, we have not big data because one case, this is an individual case. But now we collection big data for using artificial intelligence methods for obtained optimal solution. And after this improvement, we obtain decision-making in uncertainty simple process with determined decisions. And about collaborative decision-making models, subjective objective approach to optimal collaborative decision-making. This is a metrics for all specialists, for all participants in critical case on emergency. For example, individual decision-making models, air traffic controller, pilot, and flight dispatch, and collaborative decision-making models. And difference between these metrics, in this individual metrics, factors influence of decision-making. In this metrics, collaborative decision-making models, factors influence of decision-making. This is the opinions of participants of this situation. And example presented in this report, example, flight between Lviv, Kharkiv, we have emergency engine failure here. And we are using our methods and obtained decision-making in uncertainty for collaborative personals, for pilot, for air traffic controller, and flight dispatch. This is a collaborative decision-making models. And this is a metrics for all participants in this situation, emergency situation, and factors influence on our decision. This is a objective factor of nature. And next step, collaborative decision-making, collaborative metrics. And in this situation, if we obtained optimal solution, Borispil, in this situation, this is an optimal solution and solution of all team, of all participants of this situation. and results. Result you can see on this slide. And in future, we have to create intelligent decision support system for collaborative decision making for all operators in a navigation system. And little information about our department, a navigation system department. We teach pilots, air traffic controllers, engineer of service air navigation system, and operator of drones. And our laboratory, and now our teachers teach in foreign country, and our laboratory, this is my diploma students, and air traffic controller and tower. And our students have training in Eurocontrol and my course decision making for bachelor, for master and postgraduate students too. Decision making, and our books we are publishing in Poland, in Ukraine, and in USA. And you can see conclusion about this report. Thank you for attention.
Thank you very much for your presentation, and now we have short time for questions. Please ask your questions using chat or by raise your hand. I have one question, if it's possible. Please, what about artificial intelligence support in your system? Which function are performed using AI? I did not understand this point because slide.
I remember about artificial intelligence and support of opinion in emergency, for example. No, our aviation specialist said that the main opinion only human in emergency, but we have simple operation, many operation. In this situation, we are using intelligence system for big data, for forecasting, for automatic proceeding, for example. But now we have we want to create artificial intelligence system for team, for machine, and for humans, hybrid system, because we have different situation and different solutions. But emergencies, this is the first case, and artificial intelligence. No, this is a priority. Artificial and on nature intelligence in emergency. As a result, human in emergency have opportunities. You understand about human? The human, the main operator. For example, pilot. This is a responsibility for flight, for success flight.
Okay, thank you very much, Professor Shmylova, for your presentation. And we have one question from Ted Kachansky. Please, very short question.
Yes,
Ted.
very short. Very nice, spasibo for the presentation. The question is, with artificial intelligence, we depend on training. We don't have a very good track record with attempts to make artificially intelligent systems that behave like humans. Humans can respond to a spur-of-the-moment thing. Computers don't do that very well unless they've already had experience with it. Do you have any comment on that?
Oh, thank you. We prepare data for artificial intelligence using models and decomposition of data on parts, because in aviation we have not big data for search optimal solution in emergency, for example, and medicine too. Medicine, aviation, this is a complex system and complex situation. Firstly, situation for decision, and artificial intelligence only prepare date, statistical date, but we have not big data. This is a problem. But combine models, individual models, collaborative decision models, and decomposition big data, and using artificial intelligence in this situation, he obtained result. But human main, our pilot say human main. And recently we have visual landing and in automatic landing, but now this is a combined visual and automatic landing of aircraft now. Only combine decisions.
Okay, thank you. Any other questions? No, thank you very much. One more. I would like to invite for in the next presentation our colleagues from Suleiman Demirel University, Olimjan Baymuratov, and Sergei Ignatyuk, National Aviation University, Ukraine. Topic of presentation is mobile application for healthy maternal behavior in order to reduce fetal mortality. Please please share your screen and start your presentation.
Yeah.
Can you hear me?
Yeah.
Okay. Yes, now we hear you.
Hello. Sorry for this. I don't know why it's disconnected. Can I show my presentation and video, the parallel session? So it's only shared desktop or my video. It's present with window and selecting my presentation. So it's normal?
Yes, we see your presentation and hear you. Please start.
Okay, thank you. So which no. So hello to everyone. The current presentation, it's results of research and parts of results of research developing of mobile application for healthy maternal behavior in order to reduce fetal mortality. I'm Baymuratov Olimjan from Suleiman Demirel University. Today we have.
Can you switch to the slide presentation mode? It's very small on the screen.
Yes. If you, Professor Baymuratov, please full screen.
Yeah, I'm using full screen. Real now. Can you look?
No. We see. Please. Yes, we see your presentation, but not full
screen.
Screen. Yes. Yes. All was okay. Just you need to share all screen.
No, it's not. Presentation. Oh my God. How it's presenting?
Don't worry, we are waiting.
And then now?
Okay, VC, please slideshow and begin from first slide. No. Okay.
It's normal?
Okay. Please continue.
Okay. The current title of paper, Development of Mobile Application for Healthier Maternal Behavior in order to reduce fetal mortality. The main problem of this research, it's understanding more complex process and understanding functionality needing to support and medical support, IT support, and creating applications in the current direction. So the current presentation consists of some contents, introduction, objectives, methodology, and some items you can look on this slide. The timely healthcare delivery is often based on the solution that provide informational assistance and the support. So basically, the current solutions are oriented to mobile applications and the systems supporting to every steps and oriented to some fields of healthcare for the preservation of the health and the scope of mobile application in the medicine is quite wide and relevant, which allows you to comply with the indicate of principles and the preventions of the field. Various factors of IT solutions were identified in order to provide various methods of information support during pregnancy to a woman. So the pregnancy process is very difficult process consisting more parallel section of supporting medical parts and specialist doctors and the supporting informational and the current scientific direction oriented to defining some parameters and understanding difficult process of supporting information parts and improving quality of information supporting with mobile application. So some statistical information of our countries, it's 94% about the number of internet users and the total population and some residents and some areas where use mobile application and medical services for supporting in pregnant women. So prototype and the desktop application prepared with Android operating system and the web application. So for all pregnant women, the application aims its fast interaction and the high quality communication with operators of medical centers. So who is oriented for supporting current women. Some objectives defined in this research process. You can look on this slide. Can you hear me?
Yes, we hear you.
Okay, so I can continue. So some objectives consist the use modern IT tools for developing of consulting and the reference system available to everyone online and improving some process in information supporting and creating centered system using with mobile and every devices. For example, it's desktop and preparing adaptive interface useful to users. Methodology of research consists of research types. It's qualitative methods using original data, So it's statistical data from our government, stat.gov.kz, and there's some medical dates, government data sources, and the experimental analyzings using statistical analysis, comparative analysis methods. So the main information source, it's Archive, PubMed, ScienceDirect, Scopus, the currently 10 popular data sources. So we're consisting results of research, projects, nowadays solutions. It's not full research methods defined here, surveys, experiments, and analysis, and creating system for understanding current situation. And the research methods, it's quantitative methods, previous researchers and the previous works, it's used in the current research time. So this survey, one of these methods, it's creating survey to identify important points for this research. And survey was conducted in this format. We made a survey of 10 questions. It's the first parts of defining, understanding some of the main points and the indicators, prepared on the 2 languages, Russian and the Kazakh, the current languages. The city of Taldykorgan populations, you can look at these numbers, and the village Urjar district. So these 2 points where medical specialists and the medical centers supported in the research process for understanding the main criteria and the points for creating and improving mobile application and information system, so useful for users. Some results of survey, for example, it's understanding age and how many children have the current time, understanding which functionality defined to using with mobile application, and understanding emotional states of users. So because it's very important in pregnant time. We are define some features and the parameters for creating system, and understanding which type and the structure needed developing for new application. So the current structure of mobile application, it's simple structure of mobile application where it consists of web application connecting with database management system, and connecting with iOS application and the Android applications, and they define the main functionality with questionnaire. It's all functionality integrated the current platforms, Android and iOS, and the web too. And the web is prepared with adaptive interface, so you can use web application adaptive to every interface of devices. So it's simple structure of mobile application and the structure of the system. So the more use, you can look at the structure, the more use and the more popular and the functions of the system is chat and turning on geolocation, and define some organizations, mistakes and emergency call, records data in the pregnancy calendar, and so more functions defined after survey. The main following functionality, so it's a text relation, frequency asked questions. It's very important because sometimes we have limitation of time talking with medical centers, experts or doctors. So some questions you can reading or watching with video, or understanding some process and understanding of priority, the current situation, or other some bio process. So, and the second part of understanding and analyzing functionality of application, it's comparative analysis of application. So we have about 50 applications and the systems, and we are analyzing of all functionality. You can look on the table. One, classification of mobile applications, and it's a checklist in the table, so presenting which functionality is the main functionality integrated or using the current system or application. The prototype of mobile application, so prepared with the first steps on the simulation, and the next it's programming platform. It's mobile and the desktop application with registration process, special ID numbers. In our countries using people's ID numbers. It's a government rules and regulations to identification persons. So in the medical, every medical systems and the government systems using identification process with the current ID. The desktop application is prepared too, and all functions developed with consultation of medical persons and centers and users too. Results of realizations, applications, and the systems we have today is copyright from National Institute of Intellectual Property, Kazakhstan. Number of and the additional information you can look on this slide. So finally, what's the real tasks of users will the application solve? They help in fact fast communication and ensuring high quality interaction with operators of medical centers. Maybe it's doctor, or maybe it's expert, maybe it's defined some medical specialist. Save time in the form of detailed video recommendations. So after analyzing of understanding some situations or understanding informations about the pregnant situations, so more users understanding with visualization technology, it's video and infographics structures. So provide reliable medical information for the population of the Republic of Kazakhstan in accordance with the requirements and regulations. So, and some documents of medical and the legislation documents of regulation from medical parts from Ministry of Medical and some documents of regulation of information and management, medical information, protecting information, all parts implemented in developing process in mobile application and the web applications. So, but it's all legislation documents and the regulation documents defined from managing Republic Kazakhstan and oriented only the Republic Kazakhstan. So the practice and the research, the current research, I hope will help to improving process of monitoring and managing information in medical system. The results consisting of the analysis functionality of application and the system more than the main 30 existing today since 2011 years, and the prepared adaptive structure and the centered structure of mobile application and the system. The main functionality has been identified, the more function and the more discussion we have in selecting process and defining priority of functionality in developing process, because we have 3 parts of interesting parts to every functionalities. The first is users. It's more oriented to video and other visualization content. The second, it's medical experts and the operators, who is oriented of optimizing operations and operation cycles in communication process. And more features from developers and experts for using and improving some informations and recording informations of chats or any connections in application and the systems. And they prepared mobile and desktop application for using some users. Okay, in the conclusion, so all algorithms of identification persons, it's optimized, and some methods of optimization and optimization of operating cycles in developing process oriented to improving some quality of communications, improving quality of recording information, and identification of information of some maybe incidents, maybe actions, any process in the current software environment. So, and the main aims of this research oriented to improving quality of medical system and the mobile application for support people's and any operations on this running on this software and the software environment. So thank you for all. If you have questions.
Thank you very much, Professor Baymuratov, for your presentation. And now we have short time for questions. Dear colleagues, if you have, please raise your hand. Or I have a very short question concerning what about cyber protection, information protection, cyber security issues in your project?
Okay. Yeah. It's good questions. It's very important in the developing process because integrating the complex system with government system and protecting personal information and protecting transactions between connections in a laboratory. We have analysis dates for medical analysis and the personal information. So it's all a process regulated, and we have agreements to using the current dates and configure it, protecting in connection with API and the database. All regulations defined from Minister of Health, our countries, and Minister of Regulation, Information Technologies, and Security in government process. So sometimes our developers changing some connection points and changing some sessions defined of security and policy on our governments. So and the very some difficult using some libraries, for example, it's open source or oriented to fast connecting, and you need to change these methods of connecting, and it's defined its delay in the connecting process of extracting information or using a system. So it's very important because the current parts, information security, defined of delay and defined quality of connecting and using information. So it's not fast sometimes it's impossible using very fast information system and creating some application, because we have security policy we have some steps of identification and validation process. So for connecting and using systems, so we define optimal methods and algorithms for defining oriented fasting, connecting, and the possibles of fasting and using with saving and protecting information in the defined level of security. Can you hear me?
Yes, we hear you.
Okay.
We had a question from Ted Poshansky.
Yeah, it was a very interesting presentation. Did some work relatively recently with mobile systems in the context of emergency medical services. And one of the concerns we had was not just complying with regulatory protection issues of protecting patient data and things like that, but being concerned about hackers. Hackers basically see an opportunity to, maybe not they're malicious, they just want to have fun, but they can destroy what you're trying to do by interfering at various places. And so from the very beginning, you have to build, as Professor Rushinsky would say, you have to build trust and dependability into the thing from the very beginning, because you can't add it on afterwards.
Every parts, for example, protecting database for visualization or protecting sessions, it's oriented to working with special CCL certificates prepared with our governments, and the more configurations and the protecting session with encryption, for example, it's MD5 to protecting links of connection, and the protecting database management system, and the encryption some information in local devices. For example, it's a final devices, it's mobile devices of users. So the standardical regulations for protecting and the securing of every information of any process for transaction saving or database management system. But the current research oriented to helping and supporting users with information, video tutorials, and recommendations, and only oriented to integrating and collaborating recommendation systems and helping in urgent situation.
Okay, thank you very much. Sorry, we have not time to continue discussion of this.
Okay.
Please, please send your mail in chat. We need to go ahead because we have not time. Sorry.
Okay, I will write now. Okay, thank you.
Thank you very much, and thank you very much one more. And our next presenter, it's a team from National Aerospace University, Hawaii. I would like to invite for presentation Dr. Igor Klyushnikov. Igor will present report topic UAV fleet routing with battery recharging for nuclear power plants, monitoring, considering failures of drones. Please, Igor.
Hello, I'm share my screen.
Share your screen.
Can you see it?
Yes, share your slide for full.
It's a problem because I share in full screen, but in it doesn't.
Okay, now it's okay. Please continue. Oh,
sometimes it's happened, but I don't know why. So, the organizer and participant of conference report UAV fleet routing with battery recharging for nuclear power plant monitoring, considering UAV failures are presented to your attention. A report include 3 parts: introduction with motivation, state-of-art goal and objectives. Main results were developed of general UAV fleet monitoring mission with battery recharging, reliability-based UAV fleet monitoring mission planning model, and research of development model. And conclusion. Recent technology in onboard equipment allows small-scale UAVs such as quadrotors or quadrocopters can be used for nuclear power plant monitoring mission. A monitoring mission via with quadrocopters can involve, for instance, covering the whole target monitoring stations of a nuclear power plant to gather data from them on meteorological or radiological parameter in post-accident perimeters, which can be characterized by damaging the wired network connecting measuring stations to the crisis center. However, the small battery lifetime, about 10 or 14 minutes, is a significant barrier to utilize quadrotors for long-term monitoring missions. To cope with problem, the UAV's battery have to be charged or swapped either at UAV depot, quadcopter depot, by using automatic battery maintain stations. Normally, in battery maintain station source for quickly changing at depleted UAV battery and simultaneously recharging all the batteries to form a battery replace pool. Nowadays, the problems of using UAV-based monitoring systems are considered in many studies, but many of them considers on the planning with missions without special requirements to efficiency of applications all UAV fleet in these missions. And in this case, in our work, we consider reliability issues related to both UAV and automatic battery maintain stations utilizations. The goal of this work is develop and research a set of reliability-based UAV fleet monitoring missions which used for nuclear power plant monitoring, and planning with utilizations with battery recharging. The objects are present in these slides, and it's to develop general UAV fleet monitoring missions planning models, develop a set of reliability-based planning models, and research with developed models. I don't know. In these slides presented general models which used for planning monitoring missions with battery recharging. One of them were mine quadcopter depot is site for takeoff and landing all of UAVs, is used for battery recharging. Second way is presented in figure 2, whereas unmanned aerial vehicles maintenance and automatic battery maintenance stations during all monitoring missions. To understand more clearly understanding our codifications of our models, classifications of reliability-based UAV fleet planning models presents on these slides. To describe these models, we use a tuple, whereas n it's a number of main roads, mn is number of road section, and k is number of redundant UAVs which used in case where a main drone is failed, and b is number of automatic battery maintenance stations. And first models, which models described by tuple S1400 presents on figure 4. In this case, used only one main drones without any redundant drones, and quadcopter depot is used for battery replacement or charged with for these drones. And in our research, we used assumption what all UAVs can follow all roads 2 times. And in this case, after first circle of flight over all monitoring measuring stations, after that we need to replace or charge battery on board for UAV, and after that unmanned aerial vehicle flight to second round over all measuring stations. The probability of successful plan fulfillment are used as indicator of efficiency with monitoring missions, and where per main drone, per quadcopter depot, per returning its probability of reliability function of main drones, quadcopter depot, and flight on return roads for our unmanned aerial vehicles. And if with indicator equal 0.9, probability of successful plan fulfillment equal 0.313. Next model present on slide 9, and this model where we used 2 main drones, and in this case our target area divided on 2 different roads, and the probability of successful plan fulfillment is defined by formula 2, and if reliability function of main drones, quadcopter depot, and flight on return roads equal 0.9 with function is equal 0.254. In this case, we use our quadcopter depot for battery replace or recharging also. Next model, with model we use two main drones for fly over to roads, and in this case we use automatic battery maintenance stations for charging or replacing onboard battery UAVs. And in this case, we consider two different ways. If automatic battery maintenance stations is failure, our UAVs returns to main depots, and with procedures, all procedures connected with battery maintenance performed at quadcopter depot. For these models and this case, probability of successful plan fulfillment defined by formula 3 and equals 0.302. And the last models which we are considered as in our research is model when we use two automatic battery maintenance stations, and in this case the probability of successful plan fulfillment is equal 0.327. So the next step is compare of our models, and in these slides we can see what utilizations of automatic battery maintenance stations not significantly affects the probability of successful plan fulfillment. It's only from one is in our range which are considered. It's only several about 0.020. But if considered the flight schedule for UAV performing in this nuclear power plant monitoring missions, we can see what if we used battery maintenance stations, we can here reserve of time when we perform our monitoring missions. In this case, if we have limitations of which connected with time of performed monitoring missions, we can use which approach to reduce this time. So in our works, general UAV fleet monitoring missions planning models with battery recharging are developed. These models considers two ways for battery recharging. According the first one, each unmanned aerial vehicles after visiting the wall target measuring stations in its road should return to the depot, recharge its battery, and repeat its previous route starting from the first visited mission stations. According to the second one, each unmanned aerial vehicles after visiting the whole target area in its roads should reach an automatic battery maintenance stations, recharge its battery and repeat its previous route starting from the last visited measuring stations. Classification of reliability-based UAV fleet nuclear power plant monitoring missions with battery recharging and graphical presentation, some of them are given. The dependencies showing the relations of the probability of successful plan fulfillment for unmanned aerial vehicle fleet visiting for intended mission stations to the main drone reliability function for various models used, obtained and explored. Research models are based for developing and implementing the strategies of unmanned aerial vehicle fleet application in case of unmanned aerial vehicle failures. The next step will be devoted to extending our model based through considering different reasons of drone failures, including cyber attacks and on Internet of Drone Systems. Thank you for your attention.
Thank you very much, Igor. And now we have time for question. I see a few questions in chat. First one, a lot of questions. First one, do you have the ability to recharge UAV batteries from a distance or only at stations?
Oh, this is my question about distance for recharging. Distance. For recharge battery on distance or only station.
Yeah, the question is how you in your model you analyze means of recharges of UAV batteries. Is it by distance way or only at stations?
In this model used battery charge on stationary stations. And which models were developed only for research how it affect on efficiency wall monitoring missions in this in different ways.
Thank you. No, maybe in future on distance, this is the effectiveness of charging battery on distance.
Yes.
Maybe in future.
Yes, it is a good suggestions in point of view development, reliability and availability models. We can take into account these suggestions. Thank you. And second question is, what about minimum roads for the UAV? Can the
group flight of drones? This is a single drones or group flights, because different flights for single and group of drones. For control, for operator of drones, this is a different approach.
Thank you for your question. These models are a brick in chain of our research, which connected with development intelligent monitoring stations, which used UAV fleet and set of battery swap or recharging stations.
Thank you. I understood. Autonomous flight. Autonomous.
And in my mind, we can use autonomous fleet of unmanned aerial vehicles, which can perform all operations without a little use of human effects.
Yes, thank you. Understood.
Yes, thank you very much, Igor, for your presentation. Thank you very much, all presenters of first session of our workshop. Dear colleagues, we can start, and welcome our moderators, Professor Sergey Ignatyuk, Professor Sergey Lysenko.
I'm ready. So do I.
Okay, we can go ahead according with our program. We have 2 hours for all presentation. I suggest 20 minutes for all presentation and 5 minutes for discussion. Welcome our moderators. Welcome.
Thank you. Thank you. Thank you. So our first presentation is a checkable FPGA-based component of safety-related systems by co-authors Alexander Drozd, Konstantin Защелкин, Anatoly Sachenko, Alexander Martinyuk, Olena Ivanova, and Yulia Drozd. Are you here, colleagues? Who will be our presenter?
Yes, good day.
Good day. You're welcome.
Can I share my screen?
Show your presentation.
Dear colleagues, can you see my screen?
Yes, you can see.
Yes. Okay. Good day, dear colleagues. My name is Konstantin Защелкин. Topic of my presentation, checkable FPGA-based components of safety-related systems.
Can you put it on the slide mode, because it's otherwise very small? You have all these things on the side that are making it small.
Type F5 and make full screen presentation, please.
Just move on.
Your demonstration was correct, but
use the PowerPoint. Use the PowerPoint control. Yeah.
Yes.
Use the PowerPoint control to make it slide mode. Then it doesn't matter whether it's full screen or not.
Now, can you see my screen?
No.
No.
No. Not yet.
Please, sharing.
Now, my screen.
Yes, we can see.
Yes.
We can see, but not full screen. Press F5 or FN F5.
Now my title slide. Can you see?
Yes, but it's still small.
Yes.
Go to where it says on the top slide and click on slide.
Press width in your menu and full screen. Maybe.
Konstantin, when you try to share, just when you share your screen, you have to choose demonstration application.
Сейчас. Я не можу понять, в чому проблема.
F5 нажміть і все буде добре.
Ні, він і коли почати показ, виберіть режим демонстрації. Там буде у вас два вікна PowerPoint. Нам треба вибрати то вікно, яке демонструє...
Начать с первого слайда. Шоу скрин. Начать сначала. Слева окно.
Left menu.
Начать презентацию. Сначала, с первого слайда. Да.
Okay. Let's start.
Okay.
Now it's good.
Konstantin, we don't hear you.
Is it turn on your microphone?
Microphone. Microphone.
We don't hear you.
We have a new challenge after full screen mode.
Микрофон включить.
Turn on your microphone.
Окей. Окей. Все, теперь понятно.
Let's start your presentation.
Давайте, все, разобрались. Вот сейчас видно и слышно.
Yes, we can see and hear you.
Yes?
Yes.
Okay. Good day, dear colleagues. My name is Konstantin Zasholkin. Topic of my presentation: checkable FPGA-based components of safety-related system. Object of the increased risk in power engineering and on transport become natural surroundings of the human. They permanently add in the number, complexity, and power. To constrain risk, it's necessary to develop information technologies implemented into inform and control safety-related system. Safety-related system are development of computer system with diversification of the operation mode by its division into normal mode and emergency mode. Motivation and purpose of this study. This system are aimed at ensuring the functional safety of the controlled object in combination with its sound functional safety to prevent accidents and reduce loss of cases their occurrence. Functional safety is ensured through the use of fault tolerance solutions that are sensitive to source multiple failures, including hidden faults. The increased activity of input data in the emergency mode increase the checkability and reduce their fault tolerance as a result of manifestation of the large number of hidden faults accumulated during a long normal mode. This is why checkability plays a critical role in converting a fault tolerance circuit to fail-safe. The research focused on the development of checkable FPGA components that enable the transformation of fault-tolerant circuits into fail-safe solutions. The proposed method significantly expands the possibility of using the version redundancy inherent in the loop-oriented architecture to improve the checkability of the FPGA components of critical system. Checkability, best known in structure forms as testability, adds dependency on input data and become functional in operating mode and dual mode, different and normal and emergence mode of critical system. It creates a problem of hidden faults. This problem accumulation the hidden faults circuit and digital component during a non-normal mode, which characterized by low activity of input data and checkability. The emergent mode, the increased activity of the input data increases the checkability and reduces their fault tolerance. As a result of this manifestation of the large number of hidden faults accumulated during a long normal mode, which reduce the fault tolerance of digital components in emergency mode of information and control systems. Hidden faults in condition of low activity of input data. For example, Boolean operation table of sum and carry bits, the output of all other. In case of limit input data, for example, 3 input words, functional S and C are equal to stack at 0 and A or B logical function. Those input data limited during a normal mode creates structural and information redundancy, which can hide faults in the digital components of safety-related system. The increased activity and the input data in the emergency mode increase the checkability and show their faults. This slide, you can see known approach to solving the problem of hidden faults. In testing, periodic check of digital component by imitation of the emergence mode with blocking emergency protection. In the online testing, increase checkability of the digital component in a normal mode by change of the circuit of the digital component for its design. And both this approach and testing in online testing, periodic check of digital component with manual adjustment of the input data approach and emergency mode. However, this approach is very often ineffective and dangerous. This slide you can see features of main features of root architecture. Proposed method increase checkability of root-oriented architecture, which performs computation use mroot as generators of logic functions and variables. The widely used for root unit containing 4 inputs ABCD addresses 16-bit SRAM memory bit ABCD, arriving these inputs form a binary code of the address, which also the bit number in the memory of root unit. The 16-to-1 multiplexer is built of 2-to-1 switches. On this slide, you can see example of hidden false. The problem of hidden false manifests itself in the memory of the root units of FPGA components with root-oriented architecture. The F fault is hidden in case of the I bit of the root memory is addressed in emergency mode only. This fault cannot be detected by the checksum of the root program code. The method use version redundancy inherit of the root-oriented architecture. This redundancy is manifested on the extents of many versions of the program code that support the specified functionality of the some hardware implementation of the FPGA components. The basis for creating version is a pair of root units connecting the output of the first unit of the pair to the input of second unit. Each such pair allows to create two versions of the program code independently of the other pair. This pair identified by the first root unit, the pyramid scheme of 21 for root nodes contains 20 pairs and respectively to extent 20 over a million version. On this slide, you can see the model data transfer between roots. Two versions of program code which differ from each other is direct or inverse value of the bit transferred from first root and second root. Main provisions of proposed method. The method offers the organization of FPGA components operating with a sequential change of program code version as an alternative to manual regulation of input data for their most complete change in normal mode. The purpose of the version change is to improve the checkability of the circuit by moving bits in the memory of the root units. The main idea of the method is to develop the ability to move the memory bits observed only in emergency mode to checkable position that can be observed during normal mode. A complete set of versions for such movements is created with the possibility of inverting all inputs of the root. This possibility is limited when the root unit is connected to the circuit outputs. The proposed method is aimed at significantly expanding a set of versions by introducing a Z bit shift register and Z address modulo 2, where Z is number of information inputs of the digital circuit implemented in the FPGA project. Experimental verification of the method was carried out using Quartus Pi system, and the example of a study of 4-bit iterative array multiplier implemented into Sequon FPGA. The circuit of the FPGA project contains 30 wood. The values of the factor smaller than S threshold refer to the normal mode and rest to emergence mode 2 to 9. The number of danger bits that cannot move to checkable position has been reduced to 0. The FPGA circuit has become totally checkable. And conclusion, safety-related systems base their own functional safety and the safety of control objects on the use a fault-tolerant solution for which a main threat come from source of multiple failures. Hidden faults which can be accumulated during a long normal operation and manifest as multiple failures with the onset of an emergency mode. From one of such sources, they require improving the checkability of system and their components. For safety-related system, FPGA checkability is essential to transform fault-tolerant solutions into fault-safe solutions. The root-oriented architecture of FPGA projects allow to accumulation of hidden faults that disrupt the reading of data from the memory of the root units. The proposed method makes it possible to significantly increase the checkability of FPGA components by changing the version of program code and additional possibility to invert the inputs of the root units. Experiments have shown the effectiveness of the proposed method, which provides the transformation of FPGA project with low checkability into totally checkable solution. Thank you for attention.
Thank you for your presentation. Please, colleagues, it's time for questions to our presenter.
Konstantin?
Yes.
I have a small question. What is the main bottleneck of your, what is the disadvantage, maybe some limitations of your approach?
Okay. Maybe one limitation, this method can use for root units connected to output connector of circuit. For in this for a set of these units, this method maybe have some bottleneck.
Okay, thank you.
Thank you. Another questions?
Yes. Can you hear me? So
yes.
I think you use FPGA platform, yeah? For computational.
Platform?
Which platform you use for computation?
We use FPGA Intel Sequon and Intel CAD Quartus for this experiment.
So okay.
Okay. Do you have another questions? So thank you again. We can move to our next speaker. Our next speaker is Sergey Lysenko from Khmelnytsky National University with presentation titled DNS-based fast flux botnet detection approach. You're welcome, Sergey.
Okay, hello everybody. Do you see my presentation?
Yes.
Okay. My name is Sergey Lysenko. I present Khmelnytsky National University, and today I'd like to talk about one of the recent researchers devoted to the botnet detection. We have a lot of techniques devoted to this problem, and today I'd like to talk one of the evasion technique. It's a fast flux. So I'd like to talk about DNS-based fast flux botnet approach. And so actually I'd like to talk a few words about botnets, our background, main idea and solutions, and of course obtained results of our research. So let's go. During recent years, such a phenomenon as botnet has been one of the most dangerous and most suspicious types of malware. Botnets are the powerful for the cybercrime such as DDoS, banking fraud, cyber espionage, and malware distribution. And the vast majority of botnets use a DNS system to control the infected computer system, and using the DNS service gives an attacker an ability to anonymously and flexibly manage the botnet and increase its reliability. So in order to develop, control, maintain, and conceal the infrastructure of botnets, command and control, we will see CNC. Cyber criminals use a variety of techniques, including DNS-based evasion techniques. And one of the most difficult to detect and actively be used by botnet masters evasion technique is fast flux. So the detection of the botnet and the countermeasures implementation in order to determine their activities is complicated by the possibility of anonymous management and dynamic geographically distributed structure of botnets. Thus, given the growing number of cybercrimes committed using botnets, the urgent task is to construct new approaches for botnets detections to boost the detection efficiency. In this slide, you can see one of huge information present of state of botnet attacks and versus 2020, now 2021 demonstrates that all attacks still are growing up month by month. So in this situation, of course, the task is to try to develop new approaches concerning increasing of botnets detection efficiency. So I'd like to talk just a few words about our previous results during the 10 years. We have a huge research techniques. Firstly, we used only multi-agent system. 10 years ago, botnets only started its spreading around the world, and such mathematical operators such as multi-agent systems enables us to detect some botnets. We spread some units in different computers in the network, and using multi-agent system, it makes it possible to detect them. Later, we tried to develop such techniques based on DNS, and it enables us to make it possible to detect evasion techniques such as DNS tunneling, domain fast flux, and so on. And during the 2 or 3 years ago, we developed such detection system as bot grabber. We named it just kind of framework software distributed on the some network infrastructure, and it has an ability to recognize the cyber attacks and to take into account malware activities not only on computers, computer system hosts, but also in the network. So let's talk about fast flux techniques. What is it? So it's very interesting technique because it uses DNS and it enables attackers to mask botnets by its quickly shifting among the network from host to host, from a segmentation from network to network of compromised hosts, and the acting each uses proxies, and it enables cyber criminals to delay or even evade detection. Also, fast flux enables botnets to hide behind rapidly shifting network and also use phishing, hide using different addresses, even legitimate domain names, and also it is hard to detect them. So to start with developing of such techniques, we have to deal with botnet lifecycle, and the first step is, of course, botnet has to infect the target host, then register the infected system and to connect with bots and its CNC. The main part of its functioning in the network, of course, is executing of its built-in commands of the infected system, and maybe make updates. And after its functioning, most botnets delete itself after its execution, because frankly speaking, during maybe 15 years ago, malware tries to show its presence in the hosts and to do some harmful actions. Now the main task of attackers to hide its presence, and of course botnets try to do it in evasion manner. So unlike the uninfected computer system, the local network, which typically use local DNS servers for DNS queries, infected computers can also use free DNS services and their own. So in this slide, you can see a scheme of establishing the connection between the botnets and CNC server using DNS. And one of the characteristic feature of DNS queries from the infected computer system is the group activity. It's very important, group activity, and the botnets perform the simulatedness and or concentrated in a short period of DNS queries when attempting to connect to CNC servers to perform a procedure of migration and to execute the actions or to do download the malware updates. In situation when DNS resource record concerning the domain name were cached by the DNS client of the computer system, the repeated DNS request does not go beyond the local DNS cache of the computer system before the TTL is expired. And a lot of botnets ignore the duration of TTL period presented in the response from the authoritative DNS server to the DNS request. It means that the component of botnets tried to clear the local DNS cache and resend the domain name before the end of the TTL period. It allows bot must increase the flexibility and reliability of bot management, and the scheme of repeated DNS request for domain name before the end of TTL is present on this slide. We can the version when in case of DNS response cache is in local DNS cache, and after clearing the local DNS cache. So to create an approach, of course, we have to investigate all components, all aspects, all architectures of botnets, and to do it, we had to construct its model, and to define it, it includes the set of domain names, IP addresses, CNC domain names, numbers, number of IP addresses, number of authoritative servers domain names, number of its servers IP addresses, and so on. This model also takes into account architecture type, protocols employed for the botnet management, as well as just network protocols, and so on. So here you can see 3 types which were took into account in our research. It's centralized, decentralized, and hybrid architectures of botnet functioning. So let us consider the principles of first flags botnet functioning. The control elements of the first flags botnet have more advanced functionality compared to typical botnet CNC servers, as they are hidden behind the network from a set of external proxy servers, flux agents. Such flux agents are redirecting the request to botnets bots and the data to and from the internal control servers. In this slide, you can see the scheme of a single flux botnet functioning. The double fast flux network in its addition domain names needed for a botnet construction and are generated by authoritative name server, which are mapped to subset of cycling change IP addresses. And in this case, we can see this scheme on the slide. Given that when the double flux botnet among the name servers is more than one, it can use a lot of proxies. So several boring but very important slides devoted to the botnets functioning which use DNS. Why it is very important? Because it takes into account all components such as MAC addresses. We have to take into account IP addresses, catch DNS message sections such as header, answer, authority, and additional information. Also, we have to take into account all elements of DNS message sections such as response, name servers, and additional data, as well as code type of resource, record time, TTL fields, length of error data field, and so on. There are huge variety of fields which are very important to and they are to be analyzed. So here you can see the slide which is devoted to a set of features which we also take into account when we are trying to detect botnet which uses fast flux evasion technique, such as DNS retry timeout, amount NS records, amount rows autonomous system numbers for name servers, average distance between IP, TTL period, different versions, a number of A records, and so on. So the presence of botnet that uses the first flux evasion techniques based on the DNS can be detected using such a rule. It takes into account all features presented in the previous slides. So the process of detection can be presented in such a manner, and it involves such sub-processes as comparison procedure of black-white lists involving a set of algorithms for detection using the group activity in the DNS traffic, algorithms for botnet detection using fast flux evasion techniques, functions for localization and botnets blocking, and or everything is executing during some monitoring time. And the scheme and its time diagram is presented on this slide. But the most important, of course, is experiments to perform the model's validation with the employment of the botnets datasets. Number of experiments were conducted. The main aim of the datasets usage was to combine all possible botnets function aspects, maybe different botnets features from one hand, from other side, architectural properties and in their functional intent. And to do this, set of botnets traffic dump were analyzed, and the set of botnets behavior models at the different botnets lifecycle stages were built. And to train we used a huge number of samples of fast flux DNS traffic, as well as the test data also used some huge number of samples. I have to say that among the great number of botnet samples, such as TrickBot, LuckyBot, Azerant, Car, Netwire, and so on, samples were used to conduct experiments. Of course, during our experiments, we had to use a set of benign traffic samples. As I said in the beginning of my about GrubAssist, it's a framework, it's a software used in our department just for catch traffic, analyze traffic, as well as analyze the behavior of some software on the network hosts. And the system was involved in the experiments evaluation, and at the classifiers for making the conclusion about botnets presence, such classifiers as fuzzy C-means, SVM, and neighbor and nearest neighbors was employed. So the very important part of experiments was to find out the efficiency of detections, and the main idea was to divide all samples into 6 groups of botnets with centralized architecture with single flux, as well as centralized double flux, decentralized single flux, decentralized double flux, and very hard to detect hybrid single flux botnets and hybrid double flux botnets. And on the next slide, you can see the detection results, and analyzing them, I'd like to say that the classifiers actually has different results, and I'd like not to take into account, not to look at classifiers, but on different architectures of botnets, because when we are talking about classifiers, we know that it relies on settings and so on. But the main idea it was to test features, architectures, and behavior of botnets in the network. And here we can see that the result concerning centralized single and double flux botnets, efficiency of its detections is where I'd like to say it's good. But when we will take a look at decentralized, it has lower results. And in the situation when we are talking about hybrid single and double flux botnets, the results are not good as we expected. The efficiency was taking into account all sets of botnets. It's up to 88%. Sometimes very simple botnets, the efficiency was detection up to 99%. But false positives also has a variety from 3 to 6%. And in addition, I'd like to say our further work and some disadvantages, maybe some prospects, some perspective ideas, how we can to upgrade, how we can increase efficiency. Maybe we have to take into account more samples in our data sets. Maybe we have to use new features which weren't taken into account, and maybe employ different machine learning algorithms as well. Thank you for your attention. I will be happy to hear your questions.
Thank you very much, Sergey, for your interesting presentation. Colleagues, it's time for questions. Ted Kuchansky, you're welcome.
Very nice. Thorough investigation of this problem. The question is not directly related to your presentation, but as you're an expert on botnets, I think, do you think that the lower latency types of networks that we're seeing being introduced now in 5G and this kind of thing is going to make the problem harder or easier in terms of detecting botnets, or making botnets harder or easier to create?
Ted, thank you for your question. Furthermore, I'd like to say not only 5G will make us a lot of problems, but Internet of Things will add a huge problems for us as well, because not only 5G, when we the traffic will be growing up, and in every aspects, in the mobile devices, in smart devices, and of course attackers will use this possibility. And right you are, yes, we will obtain new challenges, so we have to develop new approaches to avoid it. Thank you.
Thank you. Any other questions?
I have a question, if it's possible.
Sure, Professor Harchenko.
Thank you very much for your presentation, Sergey. And my question is, it may be more general question. What about AI-based attacks and intrusion and protection means in context of your presentation? I mean, artificial intelligence-based attacks and intrusions. Yes.
If you're asking, will we involve such ideas in our research, or just about IA attacks present in the networks? Vyacheslav, from what part you're asking? Concerning our research, but not.
Yes, I mean artificial intelligence is powered based on there are now is a hot topic protection against AI based intrusion and attacks. I understand that is more wide than your topic of your presentation.
Yeah. Thank you.
What about your opinion?
It's a good question. Thank you, Vyacheslav, because actually it will be the war between mankind and machines, maybe, because we have to we will have to construct some adaptive approaches against IA attacks, but actually all attacks are limited by a set of features, and I suppose that if we will know the set features, we will be able to construct effective methods to detect them. It's no matter, it's just automatic botnet or driven by artificial intelligence. Thank you.
Okay, thank you. Thank you.
Thank you. Another questions? No questions. Okay. Ted has
I have a very quick question based on your answer to my first question. You were talking about the IoT, and obviously the biggest concern is that these very small scale systems with very limited computational capabilities in a certain sense, but yet are very vulnerable, particularly because most of the people designing these things don't think about security, and they put thermostats, they put this or that, whatever, and all you need is to capture one of them, and then you're into the network. Is there some sort of a generic way we can try to improve the system's security?
Yeah, thank you, Ted. Right, you are. Yes.
Okay, thank you, Sergey, again. And we move to our next presentation. Our next presentation is mine. Let me share my screen. Can you see my presentation?
Yeah, everything's okay.
Okay, thank you. My name is Sergey Gnatyuk. I'm from National Aviation University, and I want to present our research study conducted with my Kazakh colleagues, titled Structural and Analytical Models for Early APT Attacks Detection in Critical Infrastructure. Today there are many new technologies in different spheres, and it generates new vulnerabilities, new attacks, and new threats. Advanced persistent threats, or APT threats or attacks, are very relevant today. And we have analyzed the complexity and some examples of APT attacks. You can see on this slide the first APT attacks were in more than 10 years ago, and today we can see the continuity of these attacks. APT attacks are very are not simple, and they can consist of different sub-attacks. For example, DOS attacks, social engineering, malware injection, and so on. It's very actual today for critical infrastructure for objects in different sectors of critical infrastructure in the state, and we have analyzed that the main targets of attackers used APT attacks were transportation, financial services, and power energy. APT attacks is multi-phase attack, and the defenses must include different security tools and techniques. Among them, mail filtering, endpoint protection, access control, monitoring of traffic, cyber attacks detection, recognizing, and others. The analysis of research studies in this area shows us the following situation. Typical intrusion detection or intrusion prevention systems perform the following functions: monitoring, assessing the integrity of some critical resources, recognizing activity, statistical analysis, and attacks detection and prevention. So today we are not speaking about intrusion detection and intrusion prevention systems. These systems are working together in one concept titled intrusion detection and prevention system. There are many studies related with APT attacks early detection. In some works, our authors use big data processing approach to attacks defining and identification. Other authors use malware or DOS attacks detection approach to predict or evaluate the APT attack. Some authors use game theory for these targets. But existed techniques have a lot of advantages. For example, attacks events correlation, high-speed identification, and others. But on the other hand, we have the problem of intruders identification and early detection and prediction of these attacks, because a lot of parameters in cyberspace are fuzzy. So the main task of this study is creation the possibility of early APT attacks detection using developed structural and analytical models, and method of linguistic terms using statistical data. So firstly, we have defined some parameters. We have defined two categories of parameters. The first one is host parameters, for example, username, login time, processor time, frequency of logging, and others. You can see all these parameters on this slide. And second category is network settings or network parameters. For example, ARP, IP, ICMP, TCP packages. We have analyzed these parameters, and we have created the two models of parameters. The first model for host parameters with identification the fuzzy parameter, and the other and second model is network parameter models with identification of this fuzzy parameters. Additionally, we have divided all attackers into two categories. The first one is human and second is bot. Human has four main subcategories such as misinformer, spammer, cracker, and hacker. And bot category we have divided into two subcategories: spam bot and Bob hacker. After this, we have described our approach using logical and linguistic models, because our intruder did make some actions, and some parameters were changed, and some parameters are fuzzy and other are not fuzzy. So the fuzzy logic approach is appropriate for this task too. Next, we have used method of linguistic terms, and this method has helped us to calculate the value of membership function and to formalize some fuzzy parameters. On this slide, you can see the expression for this is the model, including the parameters from previous described tables, table 1 and table 2. This tuple model is a basis for this research study. After this, we have build structural and analytical models, and on next two slides you can see the example for one of our parameter described in the first table, titled login time. This parameter based on the fact of the user activity in information and communication system, and you can see a few four time intervals, and the value of linguistic variables when defined in the table 3 on this slide. After this, by the using of method of linguistic terms using statistical data, this method was described on the previous few slides. We have formalized the fuzzy parameters for our parameter login time, and you can see that you can see the linguistic standards for these parameters, linguistic standard of fuzzy numbers on the figure 1 on this slide. After this, we have created similar calculations and similar linguistic standards for all fuzzy parameters using from the table 1 where we have defined the host parameters and also identified the fuzzy parameters. These results are input data for our next step of research study, and our next step will be the creation of the rules for intrusion detection and prevention system. And in the case of using the fuzzy parameters, we can use these standards to make some rules set, or maybe big data set of these rules, and use it in intrusion detection prevention system, or maybe after some modification it can be used in different cybersecurity system, for example CM system, and so on. In this paper we have defined linguistic variables. We have divided these divided parameters into two categories: host parameters and network parameters. We have also identified fuzzy parameters and calculated membership function, and also built the standards of fuzzy numbers for these parameters. These results, as I have said, will be further used for building an intrusion detection and prevention system that can be based on the honeypot technology. And next step is rules system or data set development. This research study is a result of cooperation of our cybersecurity R&D lab from National Aviation University and our Kazakhstan colleagues. This is a part of a research project conducted with support of a grant related with intrusion detection system and security information event management system development in Republic of Kazakhstan. Also is a part, it is a part of PhD research of my PhD student from Kazakhstan. So thank you for your attention, and I'm ready to answer your questions.
Thank you, Sergey. Colleagues, any questions? Okay, then maybe a short question, Sergey. As I understood, it's just a beginning of the research, yes?
Not beginning, but just, first.
Yeah, first part, yes.
First part, yes.
First part, yes.
Without experimental study, now only some simulation.
So, why did you choose fuzzy logic at the base of detection?
I think that cyberspace is not deterministic space, and there are many processes and parameters in cyberspace that can be described by deterministic approaches.
Because why I'm asking, because as our team also used a huge number of techniques using fuzzy logics. Sometimes they demonstrated good results, but will it possible to involve dual approach? I mean that some elements maybe you will have to analyze using fuzzy logic, but some elements are very fixed, And will it be possible to involve some strict fixed values of some features that will be analyzed?
Mm-hmm. Okay, thank you. We have used not only fuzzy logic, but in some cases, I think that this approach is effective. But I think we can see on the next stage of our research, and after this, we can make the decision about the efficiency and its practical implementation.
Maybe we'll have just combine two approaches into one.
Mm-hmm.
Okay, thank you, Sergey.
Okay, thanks.
Colleagues, maybe you have questions? No? Okay, thank you, Sergey.
Thank you.
The next report, overlay network based on cellular technologies for secure control of intelligent mobile objects. Maybe Vitaly Tkachov, Andriy Kovalenko, Vyacheslav Harchenko, Mikhailo Hunko, and Katerina Khozhevska, who will be speaker. Colleagues.
Good afternoon, dear participants and guests. My name is Mikhail Vinko, and I'm speaker. Can you please
share your screen, please?
Presentation. Do you see presentation?
Yes, everything is good. Please start.
Okay. First of all, thanks organizers for opportunity being here during the coronavirus pandemic. And so, for your attention, I offer a report on the topic an overlay network based on cellular technologies for secure control of intelligent mobile objects. This is presentation structure, and let's start it. The main goal of this work is the development of principles for using existing communication infrastructures as a data transmission medium between IMOs. Today is known a few analogies. Let's consider in more detail first approach. As method of protection, it's assumed to use various methods for data encryption, particularly tunneling. But main disadvantage of this solution is the presence of the repeated request mechanism when data transfer processes are violated, tying them to one data transmission technology, which makes it impossible to use low-speed data transmission standards when switching communication standards. Okay, we can point out the elements of the overlay network and determine their appropriate functions. There is access layer, distribution layer, and core layer. And when a number of IMOs is in overlay network is pretty high, some of nodes are transit nodes. In case of not fully connected topology, we need to consider for such IMOs both availability of tunnels between nodes and their bandwidth. There could be situation in overlay network where it's required to use several tunnels between the IMO and the control central and combine them. The aggregation condition will be as first formula, where V in VPN is a bandwidth of uplink tunnels from one IMO core towards the external network. And V core to egg is maximum bandwidth of one virtual tunnel between the core and aggregation level. With large number of internal console commands, when operating is low-speed cellular communication system, it's advisable to aggregate virtual channels also between the IMO and virtual switches of the distribution level. The aggregation condition will be as second formula, where V core to EMO is data coming from control server to other EMOs in overlay network. V EMO to X, the maximum bandwidth of one tunnel between the EMO sublayer and the aggregation scheme. We choose the current topology of the overlay network. You can see this on slide number 6. And let us consider an overlay network saturated with traffic in such a way that adding a requirement will cause a denial of service. Then the dependence of number of denials on an amount of service traffic should be linear. At the same time, it's assumed that there are no topological changes and changes in the state of channels in overlay network. In course of modeling, a general view to dependence of the service traffic volume and the number of denials and the time of change in overlay network topology was obtained. The view this depends in show at slide number 7. The dashboard line denotes the percentage of capacity loss of the overlay network at the moment of the cellular network nodes denial. It's not so much necessary to determine the impact of the loss of network bandwidth, but to associate the event with the corresponding values of service traffic. To check the operability of the overlay network, which is built according to the principle proposed in the work, and to estimate the costs of service traffic in a state of constant external conditions, the above topology was used. You can see this graphic on slide number 8. An overlay network is viewed as a network with constant characteristic. The bandwidth of virtual communication channels and the matrix of requirements were selected in such way as to saturate network traffic. The function of increasing the transmission cost depending on the load was chosen constant. Since the transmission cost in this case does not play a significant role. When simulating in such condition is absence of changes in a cellular network, the expected dependence was obtained. And you can see this in graphic. Solid graphs should be the maximum possible peak values of the overlay network bandwidth share for service traffic and resulting denial rate. Dashed lines represented the average values of the representative quantities. The following mechanism was used to generate the peak values to service traffic volumes. When the simulation process was started, the update timers and the number of other parameters of routing algorithm in the overlay network were selected in such way as to ensure to simulation activation or update procedure. The second step is in research was introduce sources of denial into the overlay network. They must meet the following requirements. One of the hand, they must be in the network bottleneck, so their denials most strongly affect the redistribution of the load in the overlay network. And on the other hand, so as to exclude the probability of the cellular network violation as a result of equipment denial due to oversaturation of communication matrix with service packets. We will select the nodes operating in the bridge nodes as unsaturated nodes. When simulation over a long period, the dependencies are shown on this slide. Here we can see the peak load immediately follows the change in the overlay network bandwidth, which corresponds to change in the state of the near virtual road located in the cellular network node. The development of principles using existing information communication infrastructure as data transmission medium between EMOS on an example of several networks of telecommunication operations is presented. Proposed principles were investigated by setting up numerical experiments, a number of model and field experiments. The following attacks and impacts are considered. Electromagnetic supersession and interceptors of carrier frequency was considered. So, for further research, using the principles of constructing an overlay network based on cellular communication system for the secure control of intelligent mobile objects, it's possible to create full-fledged segments in the smart city concept schemes, providing data transmission of varying indefinitely degrees with a sufficient degree of reliability when losses vary in the range from 7 to 45%. Today, a lot of Ukrainian cities receive funding from European Union as grants, in particular for developing smart city concept and deploy it in our cities. For example, Kharkiv has a great potential to become a platform for development of concept smart city, and for further development it was proposed. Feel free to ask questions.
Okay, thank you for your presentation. Colleagues, any questions? Okay, Ted, please.
So a very interesting approach. The one question I would have is you focused on sort of existing legacy kind of cellular networks like LTE. You really haven't looked at the impact of 5G type technologies of low latency and burst bandwidths and things like that. Do you see how that will fit into your research?
Okay, thanks for the question. First of all, we saw different approaches which based on own network or using existing network. Why was chosen the LTE network, not 5G? Yeah, because LTE network is developed in a lot of cities in the world, in particular in Ukraine. A lot of cities has a LTE network, but 5G it's a new network. I mean, it will be cost more for realization than using LTE.
Okay, thank you. Another questions? Okay, one more question. As you are trying to build cellular networks, and will you make some measures to avoid the redundancy in your system? Надлишковість, redundancy. Will you do something to avoid it?
I think our work doesn't have this, because if we want build a network, virtual private network, we will not. We won't be protected. I mean that you can send the packet of some data. You can send, and this data can be see anybody. And when we build virtual private networks with tunnels, it protected our system, and I think it's not redundant.
Okay, thank you. So it was the last speaker for our session. Thank you. Thank you. No more questions? Yeah. Thank you. Okay, Sergey, maybe you have some words.
I want to say thank you for organizers, for Professor Harchenko, for the ability to be a chair of this session. And I want to thank all participants and presenters of our session. Thanks.
Okay, thank you, colleagues.
Thank you very much, moderators. Thank you, Professor Sergey Lysenko, Sergey Matyuk, for your work. And we have finished our workshop program. All presentation according to this program were down. Thank you very much. One more, our invited speaker, Professor Andrzej Rusiński and Ted Kochansky. Thank you, Ted. I understand that now you should sleep because it's the middle of the night. Thank you very much, all others from different countries. We have very nice international community. Thank you, our colleagues from Kazakhstan. And from Ukraine, from all countries. Now we have some time for discussion. If you would like to discuss any questions related to our presentation, our topic of our workshop, welcome. Thank you.
Thank you. See you the next time.
Okay. Ted, you would like? Welcome. Please.
Yeah, I will go to sleep pretty soon. But before I do, I thank you very much for a very fine workshop. And I think we covered a lot of topics with one theme that seems to be there underlying all of them. And that's that the security and the trust of these networks and these systems and all the components has to be thought about from the very beginning. If you try to put something on afterwards, it's going to be like taking a pipe that's leaking and trying to wrap it with tape or something like that to keep it from the leak will spread somewhere else. It doesn't, it may not drip right where you were standing, but it moves down the hallway or something like that. I think the other analogy everybody uses, the weakest link in the chain. If there's any place where somebody can either intentionally or unintentionally cause trouble, it will happen. And I think as the systems get more complex and we get more dependent on them, we should be more and more concerned about that issue.
Okay. Thank you for your comments, for your interesting, for your very impressive participation in our workshop, as usually. Okay. Maybe who would like to add something? No, thank you very much, all our participants once more, and hope for our next meeting or meetings next year. I wish to meet offline because online is good, but offline is better. And so thank you very much. Thank you very much, organizer of ICTRI conference. General, thank you.
Thank you a lot.
And thank you very much.
And goodbye.
Bye-bye. See you.
Thank you.
See you.
See you next time.
See you offline. Bye-bye.
До свидання. До свидання.
До відзення, до побачення.